All right. Welcome, everyone, to episode 2 of Texas Blockchain's podcast. I'm Nayan, going to be your host today. I'm a senior at UT, studying finance, and I'm one of the heads here at Texas Blockchain. So today, we're going to be with Brandon Williams. He's from SWE. Currently, he's based out of Dallas, you said?
Yes.
Nice, awesome.
Thanks for having me.
Huh?
Thanks for having me.
Yeah, of course, man, of course. So let's get a quick intro for you. So you're currently at SWE, previously at Google, software engineer, and then you were graduated from UCSD, right? Doing your master's as well as BYU, right?
Yeah. So I am a software engineer at Miston Labs,
Nice.
who is sort of the initial contributor to the SWE blockchain. And you're right. Prior to being at Miston, I was a software engineer at Facebook on their blockchain project, formerly known as Libra or DM, depending on when you followed that project. And then I was at Google working on source control before that.
Nice. So can you talk about a little bit about your switch from Google to Facebook and being involved in that, DM or Libra project and how that got you into being at SWE currently in Miston Labs?
Yeah, of course. It was sort of a funny roundabout way to sort of get into the industry. I was, like I said, I was at Google working in source control on Git. And at the time, I had a bunch of friends who were at Facebook working at Facebook source control project or their team there. And I went to go sort of interview to join them just because I was looking for a change. And went through the whole interview process, and then through just like a quirk of HR, they didn't have any more headcount for their team, and so they wanted to hire. The company wanted to hire me, but they didn't have a spot on that team. And at that exact point in time, the Libra, then it was called Libra project, was sort of getting off the ground, and they were looking for people who had an interest in the Rust language, who had background in source control and all that. So it just sort of was a nice sort of fit right off the bat there. And so I just sort of, instead of doing more source control, I fell into blockchain.
Wow, that's actually really interesting. So kind of your entry point was I feel like a little different from the traditional people's into crypto.
A little more roundabout, but,
yeah,
but I'm here now.
So was that your first, did you have an interest in crypto before that at all, or is that really like your first big dive into the space?
So a little bit before that, I had a roommate who everybody's got the roommate. Who while I was at Google, he was really interested. He was a finance guy, and he talked about all of he had some friend that invested in Ethereum early on, and hit it big, and so there was a little interest. That was sort of back when like the altcoin sort of spike was going on, and so I sort of had an interest, a little bit more interest, where I actually looked at things a little bit more then.
Got it.
Back when I was an undergrad, I had a buddy of mine who had, I think it was like an old Pebble watch that he had configured with BTC's price on it, that he would check, during class and all that. But it was just sort of this passing fancy that I didn't pay much attention to until a handful of years later when I was at Google.
That makes sense. Yeah, I feel like you're right. Everyone has like a friend or something. I was having a talk with one of my good friends the other day, and he was like, literally in middle school, someone was mining Bitcoin on like the school laptops that they had, and everyone was like looking at him like, what is this guy doing? But apparently
making bank is what he's doing.
Yeah, apparently it was like back in 2014, 2015, like during the school year, apparently got to like mine up to like 3 Bitcoin then. Oh, geez. And we're just like, so nowadays you're looking back at it and you're like, well, yeah, that he knew what he was doing back then. But so yeah, let's like kind of go into what's SWE, like what are you guys building at SWE, and how's that been so far for you?
Yeah, so being at Miston and working on SWE has been really, really fun, really engaging. The founding team at Miston all came from the group at Facebook.
Right.
And the sort of founding, or sort of the technology that underlines SWE is sort of two different pieces that were research projects that were sort of started while we were at Facebook. One of them being FastPay, which is sort of like a consensus list protocol for transiting money.
Got it. Okay.
Or transiting coins, right? And then Narwhal and Bullshark for a DAG-based consensus protocol. And so Sui is sort of those two research projects sort of come together for the main mechanism for how transactions are handled in Sui in terms of like the ordering and how the validators process them. Plus the actual smart contracting platform is Move. Which was developed also while at Facebook.
Yeah, let's dive into Move in a second, and because I think that's a super important point about Sui and how that blockchain basically exists. But to give some more context, Sui is a layer 1 in today's ecosystem, which I feel like I want to talk about actually a little bit, because what do you think Sui's actual value add is in terms of layer 1? Because I feel like we've went through a period of layer 1 wars where everyone is kind of building out a layer 1, and that's kind of a little bit under the radar nowadays. We have a bunch of layer 2s popping up, but what was Sui's vision in becoming the blockchain that it is today, and how does that play into the other layer 1s in the space?
I mean, I will say that I'm probably not the best person to go ahead and mix and match and compare the different L1s. Mostly because I'm a protocol engineer. I spend time building the projects that's in front of me. But one of the interesting things is if you do look at some of the other projects L1s that are out there. The couple biggest L1s are Bitcoin and Ethereum. Ethereum actually is a smart contracting platform you can use for doing more interesting things.
Yep.
But Ethereum has this issue where it's not high throughput. The gas fees for it are very spiky. It's really hard to sort of figure out how much a transaction is going to cost, because who knows what else is happening on that L1.
Exactly.
And so sort of some of the goals behind building Sui is to build a platform where gas fees are well known and sort of established, and you sort of have an expectation of what they're going to be, and it's not going to sort of blindside you when, oh hey, look, I'm going to have to pay multiple dollars or even tens of dollars or whatever to send my one transaction.
Right.
And then also to go ahead and be a lot more higher throughput, so that you can actually have and unlock some interesting use cases for building stuff on chain, because there's a lot of products that build on top of Sui for very trivial things in terms of, one good example is if you have a game that wants to integrate with blockchain and Web3,
Yep.
you can have some NFT that represents an item in that game, right? And so you can use the blockchain to represent ownership of that NFT and have 100%. A marketplace for that kind of stuff. But that's sort of where the game interaction and the blockchain interaction sort of ends. Mostly because of cost and because of each interaction is actually pretty expensive and takes a lot of time. Whereas with Sui, with it being low latency, high throughput, and cheap, you can potentially even unlock some interesting use cases where you can have a game actually have actions that take effect on chain. So one prime example is we've been running these quests to sort of incentivize usage of the chain, and in one of our previous quests, one of the games that you could participate in to earn points was a 2048 clone, where every single move is actually a move that happens on chain.
Wow.
So you can this sort of led to I can't remember what our peak was, but at one point in time, one of those days during that quest, it was the most number of transactions that had been done on an L1 in a single day.
That's really insane, because when you're saying gaming, it's such an issue when you have such slow throughput on blockchains existing today, because you can't actually have a great user experience in games if you can't have things move super fast for the user to do. If you basically, if we take the example of an RPG or first person shooter, you kind of interacting with a boss, and if you need that, each technically axe throw or archer could be a transaction on chain in theory, and that just hasn't been able. So that's part of the why Sui's been there and helping increase throughput. Another thing I want to talk about that you actually mentioned was gas pricing. I think that's super important. So for a lot of people, watching, what's really interesting is ETH, and the most widely known layer 1 that most people interact with today, has these massive gas price surges. So users have to pay a ton of fees when there's a lot of congestion on the network. But I actually had like a pretty unique chance to work on validator gas pricing this summer for Sui for one of the validators. And so it was like really, good for me to get like a back end view into that. But why don't you dive a little bit more into depth about how that actually works on Sui and why that's so different from Ethereum?
Yeah, so because Sui, the platform itself, is a lot higher throughput, lower latency, and all of that, it can execute a lot more transactions in a given period of time. And because of that, each slot of time that you are paying for can actually be significantly cheaper because you can actually go ahead and execute more transactions a lot more cheaply. And the way that gas is sort of calculated in Sui is a little bit more interesting in the sense that there is a sort of minimum gas unit price that you have to pay per unit of gas, and that is set by the validators basically voting for what that price should be. And every day this is sort of reset. And right now it's very, very cheap. Things are being subsidized and by staking, stake subsidies. And the whole idea being that the validators have some control over what the pricing of 1 unit of time would look like, and that price is set for the full day. And so for once that day starts, you can expect that at the beginning of the day and at the end of the day, the same transaction that you want to send is going to cost the same amount of money. You don't have to worry about spikes during the middle of the day during some hot NFT launch during that day or anything like that can disrupt other parts of the network. Now there is some ongoing work in terms of, you mentioned congestion, which can be an issue even on platforms like Sui. That's sort of something that we're working on, trying to figure out what the best mechanism is to do that. Thankfully, because we have a lot more sort of bandwidth to spend, it hasn't been a huge issue for us yet, though.
That's good. Yeah, I feel like congestion's been getting a big problem recently, especially on Ethereum as well. You're looking at not even network congestion, but validator network congestion on Ethereum, and devs having calls about that. So that's a whole other thing to dive into that isn't really there. So yeah, let's kind of go back and talk about Move, and I think that's like a really big point. And let's talk about what is EVM, limitations of that, like why Move was made at Facebook, and how you guys are utilizing that.
Yeah, so one of the main reasons for why Move was created, so Sam, one of the founders of Mistin Labs, is the sort of father of Move. He's the one who created the language during his time at Facebook. And it sort of came out of the observation that there's lots of user error or the programmer error when it comes to writing code for EVM and Solidity and the like. And at around the same time, Move takes a little bit of inspiration from the Rust programming language, which has this sort of strong sense of ownership and this notion of eliminating memory vulnerabilities, so it's a memory-safe language, and it sort of removes this whole class of bugs that exist using other languages that the programmer no longer needs to think about. The compiler can sort of check that work for them, and so the compiler can sort of help you in building a system or building a program. And so taking that as some inspiration, Move was kind of born in terms of like, well, how can you build a language such that you can sort of remove a whole class of problems that can exist in programming in EVM. One good example of that is this notion of having resources be sort of a first-class citizen, in the sense that, like, if I have a painting, or if I have a coin, right? If I have some money, if they're, depending on the language that you're writing in and the environment in which this smart contract is being run in, you could run into a situation where the programmer takes in some money, wants to deduct one coin from it, or $1 from it, and then like return the remainder back to the user's wallet. Well, what happens if they forget to do that returning of that amount to the user's wallet? Instead, they just drop it on the floor. Well, now that the remainder of that balance is just sort of gone.
Right.
Whereas in Move, due to this programming language term called linear typing, you can construct a resource or a type in such a way that the compiler is going to help aid you in preventing you from, say, dropping some coins on the floor or a painting on the floor and then having it just be gone for forever.
Whoa. That's really interesting. There's been a lot of research happening then at past for the Move and stuff. Is there any developments that you guys want to talk about or that you can share that are looking for moving forward for Sui, and like how that's looking in the roadmap?
Specifically for Move, or just other things in Sui?
In general, we were just talking about Move, so I was referencing that. But in general, is there anything that you guys are looking forward to in the entire ecosystem at MyStem?
Yeah, so one of the bigger things that right now is we're excited to sort of get rolling out pretty soon is this concept called ZK login. This is something that the research and cryptography team at Miston has been working on for a number of months now. But this notion of being able to use your Web 2 identity to be able to quickly and easily essentially create an identity on chain using common OAuth providers like Google, Twitch, Facebook, for example. So now you open up this world where you can say a game wants to have some interactions on chain. You can have your users sign up for your game by just logging in with like a Google account, and then transparently behind the scenes they can manage a on-chain account for them, and the user doesn't even have to know that this is happening on their behalf. One of the biggest hurdles to onboarding in Web3 is this whole the first thing you have to do is create a wallet. Well, most people have no idea what a wallet is. They don't know what a seed phrase is. They don't know what public-private key cryptography is. Yeah. And so, but everybody knows, oh yeah, I can log in with Google, or oh yeah, I can log in with Facebook. This sort of lowers the barrier to entry. And so yeah, the whole idea is that you can sort of, using zero-knowledge proofs, prove, the validators can validate that, Google or whatever has signed, has validated that this particular entity has, access to this on-chain account.
Wow, that's actually that's a super impressive, thing to think about, because account abstraction has been a super, hot topic recently, and I feel like that is one of the, if not the biggest hurdle in bringing on that next set of people and expanding what Web3 means to like the entire just like world and just consumers in general, like creating the user experience at that consumer point and making that just seamless. Because over the last 5-6 years, I feel like we've all seen like Google, and you just click to sign with Google, like a one-click system on like so many platforms. It's made it super easy for everyone. So being able to do that, so I feel like that's a huge step, and I don't really think I've seen anyone do that. I think that's like the first of its kind almost.
As far as I'm aware, it is.
Yeah. Wow.
Yeah, and I mean when you pair this with some other things that you can do with Sui too, you can have sponsored transactions where you can have another account pay for the gas for the transactions that another account is sending. Yeah. And so you pair those two things together, and you can actually get into a situation where you can have all these on-chain interactions pretty transparently to a user. And so now you basically are getting, blockchain, you can either have it be value add, or you can build deep integrations with the blockchain, and you don't need to necessarily lose a huge percentage of your potential user base when they show up, and the first thing they have to do is click connect your wallet. And now you don't have to do that. You could potentially just say, hey, log in with Google, and then now this is how we monitor, this is how you log into our app to begin with. And then sort of transparently behind the scenes, you now have a blockchain account that is sort of managed on your behalf. And yeah.
I feel like that's, that seems like the at the moment, the golden picture of what people want when it comes to like having an account is just, that's like, I feel like the last 5-6 years, that's what everyone's talking about. Like, how do we get people to be part of Web3 without even knowing that they're part of it? And so it seems like a really cool first step. So I want to go back. We've been talking about gaming as like our main use case so far. We're talking about account abstraction or gas fees. What are some other, use cases that Swee's been super involved in? And where do you see, like, what do you see people building a lot of on top of Sweet so far?
Man, I probably am not the best person to ask about that.
That's okay,
I'm not super involved with, most of the third parties that are sort of building on top. I know a little bit of what's being built. So there's some gaming integrations. I know that there's some DeFi work that people are working on. Because there's this central limit order book, deep book that is sort of a first class citizen in Sui that can sort of be used as an order, distributed order book for DeFi. Let's see, what are some other use cases that?
Yeah, I feel like you've touched on like the big ones. I feel like a lot of financial, like exchanges and stuff are starting to like be part of Sui is what I've seen, just due to like low cost is such a big thing. Like people want as low transaction fees. Like I don't want to pay $6 to send something to someone. Like I just don't want to do that, right? Like that's why Solana was like a huge hit when it came out. Super like low transaction fees, pennies, right? So I feel like financial incentives are big. Gaming, as we were talking about, I feel like it's gonna be huge on Sui now because you're talking about the ZK account abstraction. Like
ZK login.
Yeah, ZK login, right? I forgot the name. Yeah, it's with ZK login and like having low latency, allowing potentially, having actual transactions on chain of the game. I feel like that could completely change the experience. So I feel like those are like really big use cases that we've been talking about. I have another, just one more thing is we've talked about Sui's throughput, and I think that's a lot to do with like parallelism, right? And like that entire architectural system. You want to talk about that and how it compares to single sharding a little bit more?
Yeah, so one of the interesting things about the design of Sui in general is that unlike other blockchains where when a user submits a transaction, that when that transaction executes, it acts as if it has full access to the entire state of the chain at that point in time when that transaction is executing. And so because of that, it's really hard to sort of sequence and parallelize two transactions because transaction A could touch the same state that transaction B touches, and without executing them, it's hard to know if they are going to touch the same state. One of the interesting things about Sui is that all of your dependencies are all defined up front in your transaction. Sui is object-centric, so everything, the abstraction is a Sui object, and everything you do, touches an object. So you can have a gas coin as an object. You can have multiple gas coins. If I want to pay gas, I have to provide my coin as input in my transaction. And so this allows us to do some interesting things in terms of parallel execution of transactions, because up front, that just looking at a transaction before you even executed it, you know exactly which objects it's going to touch. And you know that by looking at transaction A and transaction B, if their inputs are all different, they're all disjoint, then you know ahead of time that they can be executed completely in parallel, and you have no issues of them ever colliding and touching the exact same state. So this opens up, this is one of the reasons why we have such high throughput, is we can parallelize these transactions. And in the same vein, if you have, there's sort of two different types of objects in Sui. There's single owner objects, which is a single address owns it, which means that only the address that owns it can use it as an input to a transaction. So if I have an NFT, and that NFT is represented as an owned object on chain, then, and this is mine, it's owned by my account, I'm the only one who can ever reference that NFT on chain. So you wouldn't be able to send a transaction referencing my NFT. You just wouldn't be able to, because when you sent the transaction, the validators would just say, hey, you don't own that object, you can't use it, and the transaction's never even actually executed. It's sort of rejected before it's even begun. And then there's shared objects. Shared objects are objects that don't have any single owner. Multiple transactions from different accounts can all touch that object. And those objects are sequenced in a total order by consensus. And so in that way you can build interesting programs and interesting interactions on chain products by having this sort of abstraction of owned objects where you have ownership over something, or maybe you have like an NFT, or maybe you have a shared object like, say, an auction house. And so maybe you have a shared object that represents ownership of or represents an ongoing auction, and multiple people can place bids on it, and consensus will order when those bids come in. And because when you send your transaction, you have to reference the objects that you're touching, the execution engine can know that, oh, hey, look, these two transactions are touching the same shared object. Consensus has told me that transaction B comes before transaction A, and so transaction B gets executed first, and then immediately when that's done, we can start executing transaction A.
Got it. That makes sense. There's a lot of, that really would, like, the parallelism aspect there actually allows for throughput, so that's really cool to hear. Last question, as just a whole, what's in your concept, as like where you stand as an engineer at Sweet and Myston, where do you think the vision is for Sweet in the future? Like what are some of your thoughts on that, especially as layer 2s are becoming huge? Where do you feel like Sweet's gonna go, and like what are your thoughts?
Yeah, I mean the industry is still evolving. It's still very, very new, very, very early. The whole industry as a whole has a lot to learn. Has learned quite a bit over the last 10 plus years that it's been around. Sweet in particular, we're really trying to drive adoption and try to capture more users who are not necessarily crypto native. So, like I said, the whole idea of ZK login enabling people who aren't necessarily super familiar with Web3 and don't understand all of the nuances about how do I create an account, how do I create a wallet, all that kind of stuff, coupled with the fast throughput, the quick throughput, we can sort of help empower other developers to come up with new and creative ways to use the blockchain with the excess throughput that exists that doesn't necessarily exist in other chains. And so that's sort of the two driving forces that I see is, how can we make this thing super performant and cheap so that we can open up, allow people to build new, cool, interesting things that we haven't seen before. And then also, how can we make it the UX of it, the user experience, very simple so that your mom could go ahead and easily interact with the blockchain that
it used to be almost impossible unless you spent so much time on there. Yeah, right. Well, thank you so much for joining us, Brandon. It was a pleasure, and thank you guys for listening in to TXV's podcast this week. Join back for next week. Thank you.